Environmental impact of corrosion inhibitors, what you need to know. Corrosion inhibitors are chemical compounds that are added to materials to prevent or slow down corrosion. They are widely used in various industries, such as oil and gas, automotive, and construction. To protect metals and alloys from the harmful effects of corrosion. However, as with any chemical compound, corrosion inhibitors can have an environmental impact that needs to be considered. In Is article, we will discuss the environmental impact of corrosion inhibitors and what you need to know about it. Corrosion inhibitors can be classified into two main groups, organic and inorganic. Organic inhibitors are usually derived from natural or synthetic compounds and are commonly used in the oil and gas industry. Inorganic inhibitors are usually based on salts, such as phosphate or chromate, and are commonly used in the automotive and construction industries. One of the main environmental concerns with corrosion inhibitors is their potential toxicity to aquatic life. Organic inhibitors have been reported to have acute toxicity to fish and other aquatic organisms, particularly at high concentrations. Inorganic inhibitors, on the other hand, have been associated with chronic toxicity, which can accumulate in sediments and affect the health of bottom dwelling organisms. In addition to their impact on aquatic life, corrosion inhibitors can also have an impact on soil quality. This is particularly evident in the construction industry, where corrosion inhibitors can act into the soil during construction and cause contamination. Over time, this can affect the soil's ability to support plant growth and ecosystem health. Another environmental concern with corrosion inhibitors is their potential to contribute to air pollution. This is particularly evident in the oil and gas industry, where the use of organic inhibitors can release volatile organic compounds, VOCs, into the atmosphere. VOCs can contribute to the formation of ground-level ozone, which is a primary component of smog and can have significant impacts on human health. To mitigate the environmental impact of corrosion inhibitors, several approaches can be taken. One approach is to use less toxic corrosion inhibitors, such as those based on phosphates or molybdates, which have been shown to be less toxic to aquatic life than other inhibitors. Another approach is to use corrosion inhibitors sparingly, using only the amount necessary to provide adequate protection. In addition, industries can implement measures to reduce the release of corrosion inhibitors into the environment, such as implementing containment systems or treating wastewater before discharge. Industries can also utilize non-toxic corrosion protection methods, such as coatings or electrochemical treatments, which do not rely on chemical compounds. Regulatory bodies also play a critical role in mitigating the environmental impact of corrosion inhibitors. The EPA also sets limits on the amount of pollutants that can be released into the environment and requires industries to take measures to reduce their impact. In addition to regulatory oversight, public awareness about the environmental impact of corrosion inhibitors is also essential. It is important to note that while corrosion inhibitors can have negative environmental impacts, their use can also have positive environmental benefits. For example, by protecting metals from corrosion, industries can reduce the need for frequent repair or replacement of infrastructure, which can result in significant energy and resource savings. Furthermore, some corrosion inhibitors can also be used to remediate contaminated soil or water. In addition to the environmental impact of corrosion inhibitors, their effectiveness and longevity must also be considered. While corrosion inhibitors can effectively protect metals and alloys from erosion, they can also lose their effectiveness over time or under certain conditions. For example, inhibitors may become less effective under high temperatures or in the presence of certain chemicals. To overcome these challenges, industries must constantly monitor and assess the performance of corrosion inhibitors to ensure they are providing adequate protection. This can involve regular inspections and testing, as well as the use of advanced monitoring and analysis tools. Furthermore, industries must also consider the overall life cycle impact of corrosion inhibitors. This involves assessing the environmental impact not only during use, but also during production, transportation, and disposal. By considering the full life cycle impact of corrosion inhibitors, industries can identify opportunities to reduce their impact and improve sustainability. Another important consideration is the cost-effectiveness of corrosion inhibitors. While these compounds can provide significant benefits in terms of protecting infrastructure and reducing maintenance costs, they also come at a cost. Industries must carefully weigh the benefits and costs of corrosion inhibitors, and consider alternative approaches such as coatings or environmental controls. Moreover, advancements in corrosion inhibitor technology and research can also play a critical role in improving their sustainability. Ongoing research efforts are focused on developing new corrosion inhibitors that are more effective, less toxic, and more environmentally friendly than current compounds. For example, researchers are exploring the use of natural compounds, such as plant extracts and biopolymers, as corrosion inhibitors. These compounds have shown promising results in laboratory tests and have the potential to be more sustainable and less toxic than current inhibitors. Researchers are also exploring the use of nanotechnology in corrosion inhibition. By developing new nanoscale materials and coatings, researchers aim to improve the effectiveness of corrosion inhibitors while minimizing their environmental impact. In addition, research is being conducted to better understand the mechanisms of corrosion and to develop more accurate methods for predicting corrosion rates and identifying suitable inhibitors. By improving our understanding of corrosion, researchers can develop more effective and sustainable corrosion inhibitor solutions. Advancements in technology and research will continue to play a critical role in achieving sustainable corrosion inhibition. The use of machine learning and artificial intelligence, for example, can help to improve the accuracy of corrosion rate predictions and identify optimal inhibitor solutions. These technologies can also aid in the development of more effective and sustainable materials and coatings for corrosion prevention. Moreover, the use of renewable energy sources in the production and transportation of corrosion inhibitors can also contribute to their sustainability. By utilizing solar, wind, or hydroelectric energy, industries can reduce their reliance on fossil fuels and minimize their carbon footprint. It is also important to acknowledge the role that individuals can play in promoting sustainable corrosion inhibition practices. By being mindful of their own use of products that contain corrosion inhibitors and advocating for sustainable practices, individuals can contribute to a more sustainable future. As industries and regulatory bodies work to minimize the impact of corrosion inhibitors on the environment, it is also important to raise public awareness about sustainable practices. Consumers can play a critical role in promoting sustainable corrosion inhibition practices. By learning more about corrosion inhibitors and advocating for sustainable practices, consumers can help to reduce the impact of these compounds on the environment. Furthermore, consumers can take steps to minimize their own use of products that contain corrosion inhibitors. For example, they can properly maintain their vehicles and infrastructure to reduce the need for corrosion prevention products. As the world continues to face environmental challenges, sustainable corrosion inhibition practices will become increasingly important. With ongoing efforts and collaboration, sustainable corrosion inhibition solutions can be achieved for the benefit of both our infrastructure and the environment. Sustainability is crucial in this endeavor, and by working together, we can ensure that we achieve it. The importance of sustainable corrosion inhibitors is not limited to specific industries or regions. It is a global issue that affects everyone. Protecting the environment is of paramount importance. As we face the challenges of climate change, ecosystem degradation, and other environmental issues, the responsible use of chemical compounds, such as corrosion inhibitors, is just one small step in the larger effort to safeguard the environment for future generations.